We present ScanEdit, which enables instruction-driven, hierarchically guided editing of complex real-world scenes. Given an input text instruction and a 3D scan decomposed into individual instances, we aim to edit the scene by rearranging relevant existing objects according to text instructions. Starting from an input RGBD scan with its geometric instance decomposition, we rearrange its objects according to an input text prompt. To handle the complexity of real-world scans, which can contain hundreds of objects, we first construct a hierarchical scene graph, where each node represents an object and edges define relations such as on top of, facing, or against the wall. We then identify the relevant subgraph for the instruction using an LLM agent. Based on this subgraph, we generate localized per-object arrangement plans. For each object in the subgraph, our planner outputs localized object-level instructions along with any new edges that should be created for the output scene configuration. These instructions are placed into an instruction queue, which is hierarchically ordered according to the hierarchical scene graph. We then use an LLM to convert these text instructions into per-object 3D transforms relative to each object's parent node, and convert the new edges into scene constraints. Finally, we optimize for these scene constraints along with 3D-based physical plausibility constraints to produce a physically plausible edited 3D scene following the text instruction. We compare ScanEdit with state-of-the-art scene synthesis methods Layout VLM and Layout GPT. Layout VLM uses VLM capabilities coupled with differentiable optimization to edit the input scene. Layout GPT adopts an LLM-based approach for layout generation. ScanEdit generates more physically plausible outputs that can follow high-level functional instructions. We can also manipulate finer-grained objects, in this case placing the books in the trash bin to dispose of them. Thank you for watching.